Let's continue on here. Express each as a single trig function of a real number and give the exact value if possible. Now, this one actually is going to work out a lot easier than the previous one because a lot of the work has actually already been kind of done for us. So let's look at this right here. In the first case, we have cos 2 pi by 3 cos pi by 6 plus sine 2 pi by 3 sine pi by 6. So we go back in time and we look up at the formulas on our formula sheet and we notice that this is just the cosine difference. So it's going to give me cos of 2 pi by 3 all minus pi by 6, which ends up equaling cos of pi by 2, which would equal 0. Now again, if you guys want, you can convert this to degrees and then handle it. There is nothing wrong with that. I'm just going to keep on trucking though, because I don't want to take up too much of your time with this lesson. Looking at this one right here, we just notice it's the sign difference. So it's just going to equal the sine of pi by 3 minus pi by 6, which just ends up equaling sine of pi by 6. And then jumping onto our unit circle, that gives us 1 over 2. The next one, we again notice that this is the tan difference, so I go tan of 15 pi by 8 minus 3 pi by 8, which will give me the tan of 12 pi by 8, which reduces to the tan of 3 pi by 2. And we notice that that one on our unit circle is just simply undefined. Now, this next one is actually quite the doozy of a question. Given that sine p equals 3 over 5, and that it's in the quadrant 1, or in the first quadrant, and that cos q equals negative 5 over 13, and we see right here that we are in the second quadrant. Fine. Now these questions, these used to be cannon fodder for exams and diplomas, so this is a good question if you're going to look over and review things. The first thing that I'm going to do is I'm going to tussle with P, and this is even before I start my questions. I'm going to tussle with P, and since it's sine P and it's in the first quadrant, we create the triangle. Now this triangle has sine, so it's going to be the opposite over the hypotenuse. And then I use Pythagoras' theorem, and that gets me that we're going to have a 1 right there. For Q, well, Q is in the second quadrant, and I draw my triangle out like this, and Q is negative 5 over 13, or adjacent over hypotenuse, and then using Pythagoras' theorem, we get 12 there. So now what I've done is I've created my triangles, and I can come up with all of my ratios. Okay, so now we go back to the first question, sine of P minus Q. So sine of P minus Q would give me sine P cos Q minus cos P sine Q. And if we look, the sine of P is opposite over hypotenuse, so that's going to give me 3 over 5. And the cos of Q, well, we already had that one, negative 5 over 13. Then it will be minus the cos of P. So I look back at P, and that's going to be